Hello, this is Chaganti Bhaskar. I am working on flywheel systems. We are using the flywheel for power generation. In this system, in this sector, we will be discussing the concept of flywheel used in power generation. So in this way, today we will be explaining to you the new concept of the flywheel to make the grid an independent grid, a happy grid, where the load can be shared at any given time by using this particular flywheel. So now we will be showing you the design, what we have designed in our factory, in our workshops, to make the flywheel a better place to be taken up in the renewable energy sector. Now the flywheel will be dominating the renewable energy sector. In this way, now you will be understanding what we have done to make this flywheel come inside the renewable energy sector for power generation. Thank you. Discussions. We'll be showing you the flywheel, what we have designed in the slideshow. Now we'll be showing you the slide by slide in this particular session. Hello, this is made in India, made by Indians, and this is purely making in India for our green planet. This is the flywheel power generation design. What we are using is a 2-meter dia flywheel of 3.4 ton made in mild steel as the rotating wheel. So we are taking 2-meter dia, and this diameter can be altered. For a bigger diameter, bigger torque is there, bigger amount of energy is there. So depending upon the tonnage and the diameter, the torque is designed. So flywheel design, this is my flywheel design. The middle is the bearing, the shaft, and outside the flywheel, this is the guide bearings supporting the flywheel for very high RPMs. So in this way, the complete design is, we are having the flywheel connected to the motor. The motor is 12 kilowatts and the flywheel is 3.4 ton. The diameter is 2 meters, and this flywheel is rotated at 240 RPM. The 240 RPM flywheel is constantly rotating at the same RPM, and the flywheel is connected to a pulley. The pulley is connected to the opposite side to a smaller pulley, that is 0 pulley. This pulley is having a particular design where the pulley is very easily rotated because of the bearings which are there on the either side supporting the shaft of the alternator. The alternator is fixed onto a stand. The stand is having a particular shaft extended outside the area which is required by the alternator, that is, it is attached by the flange. The flange is having, the flange or the coupling is having a particular pulley. The pulley is fixed on a shaft. The shaft is having either side bearings for free rotation. Thereby, when the flywheel is rotated at 240 RPM, we are trying to make the other side of the pulley to rotate at 250 RPM. Thereby we are connecting a PMG of 20 kilowatt which is rotated at 250 RPM. The weight of the inside rotor is 180 kilograms and the rotor diameter is 11 inches. The torque is 777 Nm, Newton meter. Here when we are talking about the torque of the turbine, that is a flywheel, the torque is calculated with the weight of the flywheel, that is 3.4 ton and diameter 2, and the RPM is 240. The torque is 1250 Nm, that is 1250 Nm. Here, when we are comparing the torque of the alternator and the flywheel, the alternator torque is 777 Nm, the flywheel torque is 1250 Nm. So in this way, the torque of the flywheel is more than the torque of the alternator. Thereby, when we are rotating the flywheel, which is 3.4 tons with 240 RPM by a 12 kilowatt motor, the torque we are generating is 1250 Nm, and we are connecting this particular system to the alternator. The alternator is rotated very efficiently because of the ball bearings, which are helping the other side of the pulley to rotate effortlessly. And here we are designing these ball bearings in such a way that the RPM of this alternator is constantly maintained even when the load is full on this particular alternator. Even at 110% capacity, the alternator will be rotating constantly for the maximum time it can afford, and most of the times we will be rotating at 80% or 90% efficiency. Thereby, the alternator can be working continuously for 20 to 25 years. And when the alternator is rotated at 250 RPM, the ball bearings which are supporting the alternator will be having less maintenance because of the RPM. The flywheel is also having less RPM, that is 240. There also the maintenance part is very little. So in this way, the motor is 1440 RPM. The 12 kilowatt motor is 1440 RPM. So in this way, when we are talking about the rotating of the flywheel, and this flywheel is a constant mass which is rotated at a constant RPM. Now I will be saying you the exact thing why we have taken 2 meter as the diameter of the flywheel. Here, when we are talking about the diameter of the flywheel and the weight of the flywheel, you should understand one particular system, what we have discovered in this particular area. This is a new invention. So here we are talking about hydro power generation formula, that is head into flow into gravity into efficiency. Here head is 2 meter flywheel, that is head is 2 meters, and the flow is 3400 liters, that is 3400 liter converted into weight is 3.4 ton into 9.81 into 92% efficiency. So when we are talking about 2 meter into 3400 cubic meters, that is 3400 liters of water, that is 3.4 cubic meters. 2 into, that is 2 meter head into 3.4 cubic meters of water, that is 3400 kgs into 9.81 into 92% of system will give you 61 kilowatts of energy. 61 kilowatts of energy. Now we are making only use of 33%, that is 20 kilowatt. We are attaching an alternator of 20 kilowatt to this particular moving flywheel, and 20 kilowatt system will be constantly rotating at 250 RPM. Because the weight of the alternator is 180 kilograms, the weight of the flywheel is 3400 kilograms. The diameter of the rotor is 11 inches of the 20 kilowatt PMG, just 11 inches, compared to the flywheel which is 2 meters, that is nearly 79 inches. So in this way, the difference between the weight of the alternator and the weight of the flywheel, the diameter of the alternator rotor and the diameter of the flywheel, the torque of the alternator and the torque of the flywheel should be understood very clearly. In this way, when we are generating electricity, the motor which is connected to this flywheel is just 12 kilowatts of AC motor rotated at 1440, that is 1440 RPM. And once the RPM is 240, then we will be connecting the alternator to the mains. The mains will be connected back to the battery. The battery will be giving constant supply to the home, which is using every hour nearly 6 kilowatts, which can be stored. And in this way, if we are in a position to use this particular system, we can eliminate the complete usage of fossil fuels, the dependency of the fossil fuels for power generation, the nuclear systems for power generation, the solar, wind. So in this way, when we are talking about power generation, here the raw material is zero, the purchase of raw material is nowhere, and the raw material, when it is eliminated, the cost of power generation will become very low. The cost of this particular system is 1 crore per megawatt. In this way, we will be generating 24,000 units, that is, in 1 megawatt we will be generating 24,000 units or 24 megawatts every 1 day. So in this way, we will be generating 79 lakh 80,000 units every year. And if we are in a position to sell at the rate of 50 paise or 1 rupee, we will be earning nearly 80 lakh rupees every year. In this way, we can make sure that if the government is purchasing the generated electricity as it is purchasing for the rooftop solar systems or the other systems what it is having, in this way it can help the economy of the country by making the home as an independent power generation sector. This we are calling in our research is, this is purely a cooperative power generation farming. The power generation is cooperatively made, and cooperative power generation is a new name for power sector. In this, every home is a power generation unit, power generation plant. Thereby, each house will be contributing to their might to the grid what they can every day. In this way, this system can be useful for making each home get enough money to sustain themselves and create employment simultaneously. Every home can have its own employment, its own small scale industry, cottage industry. The people can forget fossil fuels for running their vehicles. The generated electricity stored in the batteries or connected to the mains can be directly connected to the battery systems which are there in the cars or scooters or the vehicles what they are using. So they can recharge these particular vehicles with their own electricity, and they can use this particular electricity for substituting gas in their home for cooking and other purposes, for heating. So in this way, this sector will be useful for every individual, and the cost of investment is very little. In this particular sector, 1 megawatt is costing 1 crore rupees. So a person can keep 20 kilowatt, 30 kilowatt, 250 kilowatt, 500 kilowatt or 1000 kilowatt according to their required capacities, and use the amount of electricity whatever they want to their own happiness and to their development, and rest they can submit to the grid. By supplying to the grid, the government will be purchasing from each and individual home and collectively sending this particular system throughout the country. Thereby the grid will be having a complete independent system where there is no breakdown of power or no imbalance in the grid. The voltage will be stable, the amperes will be stable, the power sector will be having lot of development, lot of improvement in this particular thing. And for industries, these grids can make a lot of difference, and constant amount of power is constantly given to every factory at a cheaper price. If the government is purchasing from every home at 50 paise unit, the government can give for 1 rupee 50 paise a kilowatt hour to the industry. Thereby it will be serving to the country, it will be serving to the human development. So in this way we will be showing you the next slide as RPM 250 rotations, weight is 3.4 ton, diameter 2 meter. The torque is 1250 Nm. This is for mild steel. Or carbon fiber material, we can rotate it for 20,000, 30,000, 50,000, 1 lakh, 2 lakh RPM also. So when we are rotating at higher RPMs, the RPM will be increasing, thereby the torque will also increase, and the amount of energy generated from this particular system will be very big. In a bigger capacity also we can generate electricity, that is multi-megawatt systems, because when we are using carbon fiber material, they will be heat resistant and magnetic resistant. They don't go in with these particular systems. So carbon fiber material is more attractive and lucrative in a long run, where it can be rotated at higher RPMs. That is, when we are rotating a mild steel at 250 RPM, the carbon fiber can rotate at 2000 RPM, 5000 RPM, 20,000 RPM also without any effort. So in this way the generation part is very simple, and once we rotate the that is the flywheel, and when we discard this particular flywheel after rotating for 3 to 5 minutes in the required RPM, then the flywheel will rotate constantly for more than 1 hour and generate enough electricity to support this particular system. So in this way we are generating constant amount of energy, that is green energy, without the help of any raw material. So the next slide is the power generation is in this way is 21 kilowatt. So power consumed to rotate 3.5 ton flywheel is 12 kilowatt. The total power for use is 8 kilowatts per hour. So this is the diagram which we have discussed earlier. So if you can understand this diagram, then this diagram will give you a lot of information about the flywheel, the mass, the diameter, the RPM. So here the RPM, the mass and the diameter is the deciding factor for the torque to be decided, which should be greater than the torque of the alternator connected to this particular rotating system, that is a flywheel. The torque of the alternator is 777 Nm. The torque of the flywheel is 1250 Nm. So if we are having nearly double the amount of torque which is there in the alternator, that is 777 and 1250. 1250, that is double the torque of the alternator. The flywheel is rotated at 250 RPM. Suppose if the RPM of the flywheel is rotated at 20,000 RPM, by making a carbon fiber or a polyfiber or a composite material, thereby when we are talking about this particular system, the system will be using bigger RPMs for generating maximum torque. So here when we are talking about the torque is more on the flywheel side and the torque is less on the alternator side. In this way we are making power constantly available to the system. So second slide is, this is the flywheel we have used for rotating at 2800 RPM. This is a flywheel in our factory. This is 2 meter dia flywheel. We have already rotated this with 2800 RPM and we have generated enough electricity to this particular system, where we have connected 20 kilowatt of PMG and we have generated enough electricity to support the system back to back. What we have generated is surplus. We are using this for in-house purposes as well as to rotate the flywheel. So in this way we have already done this experiment and we have generated electricity. So the next slide is, this is the load test. You can see 12 kilowatt motor. You can see 12 kilowatt of motor rotating nearly 4 tons of weight. The motor is 990 RPM and it is 12 kilowatt AC motor. We are rotating this with a switch gear and the load is 500 kilograms. The flywheel is 3.4 ton. The diameter is 1.5 meter. So in this way, when we are talking about the load, as soon as the switch gear is offed, now the switch gear is offed and the RPM is completed. So in this way, there is no electricity into the motor. The motor gets disconnected after 3 minutes. That is, once the RPM has reached the comfortable levels as what we have designed, the sensors break away the circuit, and once it is reached 990 RPM, the motor gets disconnected by the sensors, and when the sensor is totally cutting away the inflow of the power or electricity, it is rotated in the same RPM for more than 1 hour. So in this way, the load is taken and it is rotated constantly. So we have done this particular test to prove that even with the load, the flywheel is getting rotated at 240 RPM. Slowly, the RPM of the flywheel will be getting decreased and it will come to a standstill after 1 or 1.5 hours. So in this 1.5 hours, we will be generating enough electricity, and this electricity is stored inside the batteries, and these batteries can be used for the home applications or to a factory or to the required area where we require the energy supply. So in this way, we have used this particular system and we have observed several times that this system is generating electricity constantly with the load and with the same efficiency. So in this way, we are making the flywheel to rotate and excite the flywheel for nearly 3 to 5 minutes and leave the flywheel thereafter to rotate by itself. This is the system we have adopted. This is a new and novel technology where the flywheel is rotated and energy is generated. So we are using this generated electricity for in-house applications, and seeing is believing. Please come and see. So in this way, we are making a new concept called rotor electrical generation. In this, only the rotor is rotated. So when we are talking about the rotor is PMG or diode based or silicon exciter. So this particular rotor weight is little than the weight of the flywheel. This is a very important point. The rotor diameter is less than the diameter of the flywheel. The rotor RPM and the flywheel RPM are also different in nature. So if the RPM of the flywheel is more, the RPM of the rotor is less. So in this way, the torque management is a puzzle, and we are solving the torque management issues. This is an actual system where you are seeing how the flywheel is getting rotated with the load. So the load is constantly applied and the flywheel is rotating the load and rotating itself. So in this way, this is proved that the flywheel, even after the inflow of the energy, that is when the motor is giving the flywheel the energy to rotate and the motor is stopped, the flywheel is still continuing to rotate because of the inertia, because of the weight. So in this way, the bigger the diameter and the bigger the weight is, the heavier the weight is, the more it will rotate and the more torque it can generate. So in this way, when we are talking about the rotation of the flywheel and the rotation of the PMG, the difference should be noted constantly. So that is a very important system where we are in a position to make sure that you should understand the RPM of the flywheel. See, the RPM of the flywheel is a very important factor. What is the speed of the flywheel? If you can understand the flywheel RPM, you can understand the flywheel torque also. The bigger the RPM, the heavier the flywheel, the bigger the diameter, the torque is more. So what is the torque when we are rotating 3.4 ton and 2 meter dia flywheel? Please calculate and calculate the diameter of the rotor which is connected as the load to the flywheel, that is the PMG, permanent magnet generator. And when you are making this particular system rotate, energy is coming out. So in this way you can store this energy, or you can use this energy, or you can sell this energy and make money. So in this way we are making a particular system where each house is a power generation sector. Thereby there is no need for grid and grid supporting systems. That is, small grid, smart grid, where you generate, there you distribute, is also a new concept. In this way, the flywheel technology is taking care of this particular system. So please see the RPM. The RPM of the flywheel is constantly increasing, and when it is increasing to the maximum, the flywheel RPM itself is the factor for generating the torque. Thereby the torque is transferred from the flywheel into the alternator, and the alternator is generating energy. So in this way, when you are talking about the flywheel, please understand these few different points where the flywheel RPM, the flywheel diameter, the flywheel weight, and the flywheel is one side, the alternator is on the other side. So please understand the weight of the alternator, that is the rotor weight, the rotor diameter, the rotor RPM. If you are constantly understanding the rotor RPM and the flywheel RPM, the rotor weight, the flywheel weight, the rotor diameter, the flywheel diameter, you will understand the concept. So in this way, if we are in a position to place a carbon flywheel instead of the mild steel, the system will be going on a higher RPM scale. Thereby more torque is generated and much more efficiently the system can run. So in this way we have made this particular system available for each and every home, and 1 crore rupees is the cost per megawatt. In this way every home can afford to their own choice. So in this way we are making this particular system available to every family. Thereby the cooperative energy farming is possible. So this is developed by Cow and Calf Dairy Farms Limited, which is a Hyderabad based company registered in the ROC. This was floated in 1998. So this is the company which is developing this technology. The people who have developed this technology is Chaganti Srinivas Bhaskar and Chaganti Bala. Both are scientists, and these people have designed this particular sector for the development of the country, and for the development of the human evolution. Thank you.